Welcome back to another Minecraft video. Today we're going to discuss the strangest concept, black holes. Black holes are extraordinarily dense and massive. To get things into perspective, the Earth would have to be compressed to a radius of 8.7 millimeters in order for it to become dense enough to become a black hole. This, of course, makes the gravitational force of black holes immense, so much so that not even light can escape it. Hence why black holes are black. As black holes feed on stars, the stars are ripped apart to shreds due to tidal forces. Since the star's size is so big, the strength of the gravitational forces are different on each end of the star. On the side closer to the black hole, the gravitational force will be substantially larger than the side of the star facing away. The star therefore stretches out and is torn to bits, to be consumed by the black hole. This is a process known as spaghettification, or in the 900 building, spaghettification.
The gravity of black holes is so great that it warps light. Black holes are invisible, but black holes can be found by how it affects the light around it. This is due to the nature of gravity. If you imagine space-time as a piece of flat cloth, gravity acts as dents in the flat cloth. As light passes through a great gravitational field, it can bend due to this dent in space-time. This explains how we are able to observe objects that are actually behind another object from Earth. In this diagram, a galaxy is behind a galaxy cluster, but we are able to see this galaxy because the light rays emitted from the galaxy bend around the gravitational dent of the galaxy cluster. The same thing happens with the black hole, but to a much larger degree.
Remember that gravity creates dents in the space-time fabric, which includes time. This is called gravitational time dilation. In Einstein's theory of relativity, he hypothesized that as objects move faster, they perceive time slower. If you were to travel close to the speed of light away from a clock, you would see the clock's hand move slower to you. This is because the light emitted from the clock would be reaching you in a longer amount of time, because you were traveling close to the speed of light. You are perceiving time slower. In a stronger gravitational field, objects fall or accelerate faster. Therefore, they perceive time slower. As gravity creates depressions in space-time, light would have to travel different distances. Points A to B represent the distance light would have to travel in a weak gravitational field. There is almost no effect at all on its path. Points C to D represent the distance light would have to travel in a stronger gravitational field. The speed of light is a universal constant, so since speed is equal to distance over time, and speed is a constant, a larger distance would have to be compensated with a larger time. Time conceived is slower in a larger gravitational field, and to an observer, things would appear to move slower in the gravitational field. That is why, if you were to observe a person falling into a black hole, they wouldn't just get pulled in quick. They would appear to slow down as they near the event horizon. Eventually, they'll just seem frozen in place.